Okay, Year 10. The next two lessons in our work for this week, uh, exercise 5E, questions 1, 3, all of those ones, and then the last column of 4, 5, 6, 7, and 8. You need to make sure you've done the other work, all those worksheets, and watch the introductory video as well. So let's have a look. Now remember, at this stage, we're all about graphing straight lines. Now you can have a look at the textbook, and there are some things you need to know. You need to be making your own notes as you go along. And the first two things that you need to know, if you go back and you have a look at the success criteria, the first two points are I can write a linear function in general form, and I can write a linear function in gradient intercept form and identify the y-intercept and the gradient. And that's what we're going to do today. And we're going to graph the linear function and plot the x and y-intercepts. If you can do this, you're away. And I think most of you will be able to do it because we did it last year. So, a linear function. Well, a linear function can come in many forms. The standard form is not this method over here with this d. The general form, all right, so learning intention success criteria number 1 is we can write it as something x plus something y plus something equals 0, where a, b, and c are constants represented by a, b, and c, and the variables are x and y. Now this form here, this general form, and you need to make your notes, the general form is not very useful. But it's a standard form around the world. The intercept form, which if you did the sheets, is much better. The gradient intercept form is much better. And y equals mx plus, now, over here it says b, and that's how all the old textbooks will tell you, but they've changed now and they've used c. Y equals mx plus c. So that's our intercept form, where this represents the gradient, which is the slope, which is the rise. Hold on. Equals the rise over the run. So it can be written as a fraction, a decimal, or percentage, or even a ratio. Or you can find it because tan theta equals rise over run when we're looking at it from left to right, tan theta. So you can actually find the angle that it'll make by going inverse tan of whatever the gradient is. And this is the y-intercept, where it cuts the y-axis. Now, so you need to be able to graph these. So success criteria number 1, can you make sure you can do that? And success criteria number 2, make sure you can do that. And then you're ready to start graphing them. All right. So let's have a look at these questions. Make sure you've made some good notes. So exercise 5E. Now you need to do all of these. Now you need to rewrite. Now remember, they're going to be using B, but we can use C. So rearrange these equations so that they're in that form. So you should be able to do them. But remember that the y must always be positive. So you go away and have a go at them. I'm going to do them really quickly here. So you go away and have a go at them, then come back and correct them, or correct them from the back of the book. y plus 2x equals 5. Take the 2x over the other side. It's minus 2x, and I get plus 5. And the gradient is negative 2, and the y-intercept, which I'm going to call c, is 5. And it's positive 5 because it's all of that and all of that. You have to take the sign as well. The next one, b, 2y equals 4x minus 6. 2y equals 4x minus 6. Go and have a go by yourself. Now, it's almost in the right form. The x and the y, the x and the constant are on the other side, but I have to get rid of that 2, so I'm going to divide by that 2. And remember, I have to divide everything by 2. So divide that by 2, divide that by 2, and divide that by 2. And I'm going to get y equals 2x minus 3, where my gradient is 2, and my y-intercept equals negative 3. Remember, you have to include the negative. C, x minus y equals 7. Well, this time I'm going to take the y over the other side. I'm going to get x equals y plus 7. So I added the y over. I'm going to minus the 7. X minus 7 equals y. Doesn't matter which way we write it. I'll just bring the y over this side, and I'll have x minus 7 on the other side. Now, what's in front of that x that's not normal, that you can't see? There is a 1. So the gradient is 1, and the y-intercept is negative 7. Okay, D, and what have we got for D? Minus 2x minus 5y equals 3. Go and have a go at it. Minus 2x minus 5y equals 3. Or you have a go at it, pause the video. Remember, the y must be positive. So I'm going to take that 5y over the other side to make it positive. So I get negative 2x. I add the 5y plus 3. I'm now going to minus that 3. I'm going to get rid of that 3 because I need to get the y by itself. So I get minus 2x minus 3 equals 5y. And I'm going to divide everything by 5. If that helps you, write it like that. And I get minus 2/5 x minus 3/5 equals y. And now I've got my gradient, minus 2/5, and my y-intercept is minus 3/5. Remember, you have to take the sign as well. Okay. Question 3, I'm going to let you do that on your own. They're pretty simple. Question 4. Question 4. Now, this is important. Decide if that point lies on the line. Now, I'm going to do 4, and what do we have to do? Let's go back and have a quick look. We had to do the last column. So, decide if the point lies on the line. You can go and have a go. I'm going to do 4B, and then you do C and D, and I'll do those as well. So 4B, and I'm checking whether or not 3 and negative 1 lies on this line, y equals minus x plus 2. So if I put that in for x, do I get negative 1? Well, let's see. So does negative 1 equal minus 3 plus 2? So I'm going to take the right-hand side. This is pretty formal. Minus 3 plus 2 equals negative 1. All right. Well, the left-hand side equals the right-hand side. So point lies on the line. I know that sounds like a lot of work when it's pretty obvious, but you really do need to do that. So you do the same for C, and I'm going to do F. 3y minus 4x equals 9. 3y minus 4x equals 9. Let's just double check, make sure you got the right thing. Negative 9, lucky I checked. And again, we're checking the point 3, negative 1. Okay, well, let's take the left-hand side. So we get 3 times the y value, negative 1, minus 4 times the x value, 3. Does that equal 9? Negative. So the left-hand side this time equals 3 times negative 1 minus 4 times 3. 3 times negative 1 is negative 3 minus 12. Well, that's minus 15. Negative 3 minus 12 is minus. So no, does not, really we should say does not satisfy the equation. I know this is a lot, hence, oh gee, come on. Hence does not lie on the line. So all you're doing is substituting the values in to see if they satisfy the conditions of the line. Okay. So 5, 6, and 7. I'm going to do one of each, and I'll just create some room here. And the only hard part for you really is going to be finding the x-intercept. It's the most difficult part of this. So to find the x-intercept. And unlike when we plotted points, we don't have to be as accurate because we're going to use our knowledge of mathematics to show the critical points. So, question 5. Y, 5D. Y equals negative x plus 2. Well, what do I know straight away? And this is what you've got to ask yourself. What's the gradient? Well, the gradient is negative 1. What's the y-intercept? The y-intercept is positive 2. So, straight away, I know that this equation has a negative gradient that goes through 2. So 1, 2. And it's a gradient of 45 degrees. So it's going down like that. So there's my line. And I need to label my axes. I need to label my graph. I need to label the x-intercept. And I need to label this point. Now, how do I find this point? Okay, to find the x-intercept, let y equal 0. So 0 equals minus x plus 2. Take the x over the other side, x equals 2. And that makes sense because it's 45 degrees. All right. So in each of these, you got a gradient, you got a y-intercept. L's a bit different, so I will do L. You go and have a crack at it and see if you can do it. And then I'm going to do it here. So hopefully you've had a go at it and you've come back now. And I'm going to do this one here. I'll just get rid of all of this. I'll leave my axes there so I don't have to draw it up again. And what is it? It's y equals 0.4x. And this is F. Sorry, L. Y equals 0.4x minus 0.4. That's the trick. They've written this the wrong way around. Minus 0.2x. Now, I like it as a fraction, so I'm going to write this as a fraction. Y equals 0.4 is 4 over 10 or 2 over 5. And minus 2 over 10 x. So I'm going to write that as fractions again. Y equals 2/5 minus 1/5 x, but it's not written the way I like in the gradient intercept form, which is y equals mx plus c. Okay, so I'm just going to swap these around. And remember, you can think about these as y equals 2/5 plus negative 1/5 x, which means it doesn't matter which way you write them because they're added, they're two numbers that are added together. So y equals negative 1/5 x plus 2/5. So straight away, what have I got? Well, I've got a gradient of negative 1/5, which means it's going down, it's going that way, but it's not very steep. And I've got a y-intercept of 2/5. Right. So, here we go. I'm going to call that 1. I'm going to call that 1. So the gradient, it's going down, and it's going to go through 2/5. So 2/5, actually, let's get rid of this. 1, 2, 3, 4, 5. So 2/5 means it's going through there. You don't have to be this accurate. It's pretty flat. So this line, 1/5 is really flat. So it should look something like that. And I've got to find this value. And I have to label this. So this is y equals negative 1/5 x plus 2/5. And I need to find this value. So I'm going to let y equal 0. And if I let y equal 0, I get 0 equals negative 1/5 x plus 2/5. I'm going to add that 1/5 over, so I'm going to get 1/5 x equals 2/5. And I'm going to multiply that 5 across. So I'm going to get x equals 5 times 2 on 5. The 5s will cancel, so x will equal 2. Now, look at my graph. Poor now. But I don't have to have the same scale as long as I write it. I don't have to have the same scale. Let's double check that on Desmos, all right, to make sure we're right. And what was it? Y equals 0.4 minus 0.2x. And we'll get rid of this. And we'll zoom in and we can see there it is. Right? It looks like that. So our graph is correct. Okay. Question 6 is the same, but you have to rewrite them. And question 7, it says sketch by finding the x and y-intercepts. You can do that by letting x equal 0 and y equal 0 and then just joining where they hit. So I'll do one of them, but I'm not that fussed about them. So let's have a go at question 6. And I'm going to do, I'll just do h and you can try the other ones. So 6h. What have I got? 2y. That looks like just h with the bracket, so let's put a 6 there. 2y plus x equals 1/2. First of all, I've got to write it in gradient intercept form. So I'm going to take that x over the other side. 2y equals negative x plus 1/2, because I want to write it as something x equals. And then I have to divide by 2. Y equals negative 1/2 x. And 1/2 divided by 2 is 1/4. Remember, I've got to divide everything by 2. I'll divide that by 2, divide that by 2, and divide that by 2. Okay. So now I have my gradient of -1/2, which is going down, is pretty flat, and my y-intercept is 1/4. So let's get my x and y, and remember to label them. Because this is really fractional, let's make 1 up there. Well, this is going to be really flat, so I'm going to have something really, I think I'm going to need to extend that. So I'm going to have to do it by freehand. Because it's pretty flat, it'll probably go way over there, but let's see. So it goes through 1/4. 1, 2, 3, 4. So it goes through there, and it's pretty flat and it's going down. So let's draw this line. That's pretty flat. I don't have to be 100%. How do I find this value here? Well, again, I let y equal 0. Let y equal 0. And I get 0 equals -1/2 x plus 1/4. I could substitute it into the original equation, and you can see there, if I let y equal 0, that's going to go to 0. I'm going to get x equals 1/2. I'm going to do it this way just so you can see. So I get, bring the 1/2 x over, equals 1/4, and multiply by the 2 over here, or divide by 1/2, it's the same thing, and I get 2 times 1/4, which is 1/2. So I was pretty solid there in getting those values. All right. In question 7, graph by finding the x and y intercepts. I don't mind if you do it that way or you do it the way that we've just done. I'm going to do question 7. I'll show you how to do it by plotting the intercepts. If you like that method, you can use it. I don't use it myself. But there are more ways to do it. You can do it by plotting points. You can do whatever you want. So let's take 7L, which is 5y minus 2x equals 12. Now, equals 12. Now, you can do this much easier. You don't have to write this in intercept form. So first up, I'm going to let x equals 0 to find the y-intercept. And I'm going to get 5y minus 0 equals 12. 5y equals 12. Y equals 12 on 5, which is 2 2/5. Now, let's let y equals 0, and I get 0 minus 2x equals 12, minus 2x equals 12, x equals -6. Okay, so I've got my intercepts. So y equals 2 2/5. 1, 2, about there. And x equals -6. 1, 2, 3, 4, 5. I'm going to have to extend it. -6. So they're my 2 points. And if I just get a ruler and go through them, and what I'm going to do is I'm just going to change that to there, because I'm not that, and that's 2 2/5. Now, always check, because we've only found 2 points. We could have got that wrong. 5x minus 2y equals 12. Let's go to Desmos. And what have we got? 5y minus 2x equals 12. 5y minus 2x equals 12. And there it is. Check that point. Oh, come on. 6 and 0. And 2.4, which is 2 2/5. Okay. So they're the methods you can use. I prefer doing it that way, finding the gradient, finding the y-intercept, and then letting y equals 0 to find the x-intercept. There is a trick. There is a trick to doing these when they're written in this form. Oops, I just lost my OneNote. I'll get it back up. Come on. Thank you. Yeah, there is a trick to doing it. Okay. When it's written, come on, baby. When it's written in this form. So the x-intercept's really easy. It's just this thing here, the -4. But the y-intercept, you can just change the sign of this, so make that 4, and divide by that. Well, let's see. If I let y equals 0, for that, I get 0 equals 3x minus 4. To get this over the other side, I've got to change the sign of it. Okay, so 4. And did I say 3 over 4? 4 over 3, I should have said. Divide by the 3, 4 over 3. So change the sign of that, 4, divide by the coefficient of the x. So if you're going along here, let's have a look at this one. The x-intercept, -10 divided by 4. Here, -4 divided by 2. Here, -6, no, +6, change the sign, divided by 3. Just be careful when you get ones where they're not written in that form. So look at this is a bit tricky. So you change the sign of that, so -4, and you've got to divide by -1/2, which is like multiplying by 2. So change the sign, -4, divide by -1/2, multiplied by -2, that's going to be 8. The x-intercept is going to be 8. Anyway, you can always do it by just letting y equals 0 and solving the equation. So those steps again, make sure it's written in gradient intercept form. Find your gradient, find your y-intercept, and to find the x-intercept, let y equal 0.